Welcome to True Projects. In this video, we are going to explain the project Word Revert Adversarial Examples Defense Method for Chinese Text Classification. Introduction. Chinese text classification is one of the many areas that have seen significant advancements thanks to the growth of machine learning and deep learning models in natural language processing. However, these models are prone to adversarial attacks where small modifications to input data can lead to inaccurate classifications. The word revert defense strategy stands out as a crucial remedy to address this threat. This novel strategy focuses on locating and eliminating antagonistic examples and is designed specifically for Chinese text. Word revert increases the resiliency of text classification models, ensuring their dependability in practical applications by restoring the integrity of altered words within the text. We explored every aspect of this defense mechanism in this project, as well as its efficacy in defending Chinese text classification systems. Object of the project. The goal is to develop a Chinese text classification system that uses a variety of deep learning and machine learning models, including an ensemble model, naive-Bayes, BERT, Roberta, GRU, LSTM, and CNN. Data preprocessing, model training, and Flask-based front-end integration with SQLite for user sign-up and sign-in are a few of the major phases that the project covers. This project aims to facilitate efficient and reliable language analysis by providing accurate Chinese text classification, making it a useful tool for numerous applications including sentiment analysis, content categorization, and user input translation. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. Now we'll discuss the flow of work. These are all the steps followed to build this project. The first step is importing required packages. This step involves importing required libraries and packages like NumPy and Pandas for data manipulation, TensorFlow and Keras for deep learning model building, model development, transformers for utilizing pre-trained NLP models like BERT and Roberta, and Matplotlib Seaborn for data visualization. The second step is exploring the data set. In this step, we employ exploratory data analysis to better understand the data. The third step is data processing. In this step, we clean, transform, and prepare the dataset, ensuring it is suitable for subsequent machine learning tasks. The fourth step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label processing. In this step, we employ a label encoder to convert categorical labels into numerical values, enabling machine learning models to work with them effectively. The next step is tokenization based on BERT for transfer learning and Keras for deep learning. Here we tokenize the text data using BERT for transfer learning and Keras for deep learning, preparing it for model input. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. The next step is building the model. We have used various machine learning and deep learning models in this project. The first model used is naive-Bayes. Naive-Bayes is a simple yet effective probabilistic model. It is well suited for text classification tasks, especially when dealing with a large number of features and relatively small datasets. Naive-Bayes can provide a baseline performance for text classification and is often used for its speed and simplicity. The next model used is BERT, bidirectional encoder representations from transformers. BERT is a state-of-the-art transformer-based language model known for its ability to capture context and semantics in text. It excels in capturing intricate patterns and nuances in language. The third model used is Roberta. A robustly optimized BERT pre-training approach, Roberta is an optimized variant of BERT that further improves performance. It excels in understanding the context and semantics of text, making it highly suitable for text classification. The next two models used are GRU and LSTM. GRU, that is gated recurrent unit, and LSTM, that is long short-term memory, are recurrent neural network architectures known for their ability to capture sequential dependencies in data. They are effective for tasks where the order of words matters. These models are valuable for tasks like text generation and sentiment analysis, where understanding the context of words in a sequence is essential. The next model used is CNN, Convolutional Neural Network. CNNs are commonly associated with image processing but can also be applied to text data. They excel at capturing local patterns and can be useful for certain types of text classification tasks such as text sentiment analysis. The next model used is ensemble model. Ensemble model combines the predictions of multiple individual models to improve overall performance and robustness. They can help mitigate the weakness of individual models. The next step is training and evaluating the model. In this step, we employ the preprocessed dataset to train previously mentioned models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset. This evaluation step helps ensure the models are accurate and reliable for real-world use. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we implement a web framework using Flask and integrate an SQLite database for user registration and authentication. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. Later, users provide Chinese text input, which is then translated and will be pre-processed to make it suitable for prediction. The trained models are utilized to make predictions on the pre-processed user input, and the predictions are displayed through a front-end interface, providing users with the results of the text classification task. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the dataset used. These are model files which contain algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. This is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And this is test cases text document in which I have few Chinese test cases on which we will predict the sentiment. And now copy the path of the code folder from the address bar of the file explorer. I'm copying it and open the Anaconda prompt. Use the cd command followed by space and then paste the copied path and hit the enter button. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address and the port unless configured differently. So now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. So after pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up button. Click on sign up button. So it has redirected to a registration page. Fill in all these details and click on register button to create a new account. As I already have an account, I'm clicking on sign in link. So it has redirected us to a sign in page. give the credentials, username and password. So I'm giving my credentials and click on register button. So it has redirected us to the sentiment prediction page. And here we can see an input box where we have to give the Chinese input, and the application will pre-process it and translates it and gives us the sentiment of the input. So I'm giving the input from the test cases document. So these are the test cases I have. I'm copying the first one and paste it in the text area and click on predict button. So the sentiment of this text has been predicted as sadness. Now click on home and we will input another text this time. So I'm selecting I'm copying the second text and paste it here and click on predict button. So the sentiment of wheat is happy. Again click on home. I'm giving the third one this time. Paste it here and click on predict. So the sentiment is predicted as fear. I'm giving the fourth one this time. So the sentiment is predicted as anger. I'm giving the fifth one this time. So the sentiment is predicted as love. So similarly, we can input any other text and get the sentiment of that text. Now click on sign out button to sign out. So the conclusion here is an adaptable Chinese text classification system has been successfully created. With the help of a variety of deep learning and machine learning models such as LSTM, GRU, Roberta, BERT and others, we were able to achieve LSTM models' remarkable predictive accuracy. For user registration and authentication, the use of Flask and SQLite improved the user experience. This project tackles the issue of accurate text classification and translation in the context of Chinese text analysis.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.